Okay. Okay. So let's start now. So last time we have seen that other the base values and how we can represent in per unit values. Let's have a small example. I have a circuit in front of me. If I have to find, let's say in the small circuit, current, it's a series circuit where we have a resistance and voltage across that resistance is V. Let's say the data given is we need to find value of the voltage in per unit. So we need to find this value. Let's say I is 200% and R is 50%. It's small for your example. So we need to find VPU, or we can also say we need to find VPU. Now in this case, I 200 means we can write it. I have told you we can write it also. I per unit, that will be 2. That will be 2 per unit. And I can write R per unit. That will be 0.5 per unit. You need to divide by 100 because 100% means 1 per unit. 0.5 per unit. So I know VPU is what? Relationship is very simple. VPU is RPU into IPU. I know this. VPU is RPU into IPU. Whatever the relationship exists in the absolute system, same relationships exist in the per unit system. Exceptions are there, and that I will tell you because under root 3 and 3 will not exist, will not occur in case of the per unit system. We will be coming to that. Okay. So this value. Okay, so this value is R per unit is 0.5 and this is 2 and this is 1 per unit. So this is a simple example. If you have to find the value of V in per unit, you have been given the current, you have been given the resistance value, and that resistance value will be somewhere here. Now let's come to the one of the problems. This is a common data problem in the GATE examination. This was asked. See, GATE problems are very simple. I'm repeating time and again to you people. But if you will go through my lectures, if you will see, if you are going to attend all the lectures, it will be very simple. And we will explain this per unit system in a simplest way. You'll not find in any book like this. Okay? So what it was I think in 2000, lately in the 2017 it has been asked. I don't exactly remember, but I have not written the date here. It's a single phase generator, common data, I think it is 2 or 3 marks numerical was there. Single phase generator is there, rated for 25 MVA, 6 kV and 50 hertz. Has a series impedance of this one. So series impedance where resistance and reactance is given. We have the values. This generator delivers 10 megawatts real power. So real power is given, that is P is 10 megawatts, 10 into 10 is power 6. That will be your, in terms of the watts, a 0.8 power factor lagging. And power factor is 0.58 lagging with terminal voltage of 5.6. So a generator will have generating voltage and it will also have terminating voltage, that you know. So VT terminal voltage is 5.6. Choose the base values as ratings of generator. So you need to choose the base values, whatever the ratings of the generator are. Now what you need to calculate: impedance of generator in per unit, reactive power delivered by generator in per unit, terminal voltage of generator in per unit, and power factor of generator in per unit. So before going for the solution of this numerical, let me draw the diagram first. So solution will start, and before drawing this solution, let me draw a diagram first. So what we have a resistance, we have a reactance, and we have a generating voltage here. Okay. So we have a generator. So here we have a resistance and we have a reactance, and here we have a terminal voltage, and that terminal voltage is how much? 5.6 kilovolts. It's given. And what is the value of the resistance? Value of the resistance is 0.1, and value of the reactance is J 0.5. And how much power this generator is delivering? Real power 10 megawatts. Okay, at what? At power factor 0.8 lakh. It is given. And this generator, what are the specifications of the generator? Generator is having a apparent power S megavolt ampere of 25. That means complex power S. 6 kilowatt is the generator voltage, and as normal, the usual voltage in our country is 50 hertz. Now, first, what we have to he's first we need to write the base values. See, if he has given, he is telling the choose base values as ratings of generator. So, what are the ratings of generator? There will be base values. What are the two arbitrary base values? Complex power base and voltage base. So, we have to use this for generator. If he has not given about generator, then he will specify use this and this as the base value. So it will be given in the question. There's no question that it will not be there in the question or it will not be given. So this thing will be given in the question. So let's proceed. Okay. Now we know that the base value, complex power base, is 25 MVA, because this is the complex power for the generator. Same way, I have to use the base value. And voltage base is 6 kilovolts given in the question itself. So what are these two bases? I will again repeat, these are arbitrary bases. These are arbitrary bases. Others we have to derive. Okay. Now first, what is the actual value of impedance? Given in the question, actual value of impedance. Actual value of impedance, that is, we can write it Z, will be given as 0.1 plus J 0.5. This is in ohms. That's the same I have drawn in the circuit itself. Okay. So if I have to write Z per unit, last time we discussed this, how to write actual value of Z divided by the base value of Z. Base value of Z will be ZB. So now if I have to get the base value, Z base, Z impedance is voltage divided by current. So it will be in the base values. Now let me multiply it by V base. V base, last time I have done it. So I can write here V base whole square divided by V base into S base. V base into I base is S base. We have seen it last time. So V base square by S base. I'm just repeating these things so that you can remember this. So now my aim is objective is to get the Z base, because Z base is common for reactance as well as for reactance and resistance. Base will be Z base itself only. So Z per unit will be given what? It will be given by V base whole square. What is V base? That is 6 kilowatts, 10 to power of 3 whole square. And what is this S base? S base is 25. It's in mega volt amperes, 10 is power 6. And if you calculate this 6 and 6 has cancelled. 6 by 25, 6 square will be there. So that will be 36 by 25. So Z base is 36 by 25 in per unit. Now, Z per unit itself will be what? It will be actual value of Z divided by the base value of Z. What is the actual value of Z? Actual value of Z is 1.1 plus J 0.5. It will be divided by the base value. Now, base value is 36 by 25. You can use your calculators, but I will give the exact values. This is 0.0694 plus J 0.03472, and this is the per unit value now. Now, out of this, what will be the R per unit? Although that has not been asked in the question, but we should write it. R per unit will be 0.0694 per unit, and then your x per unit will be J 0.03472 per unit. Or you can write without J also, that doesn't matter. Because it's a complex quantity, everybody knows it. I think first part of question, there's not much difficulty in solving this. You should know the per unit value of Z, and you should know, for that we should know the base value of Z. How we can get base value? You should always remember V base square by S base. Just I have derived it again to show you how I have arrived to this result. We know S base, we know V base, we can get Z per unit. Once we get Z per unit, we can split it to R per unit and X per unit. These are the values. That's what I have done. Okay. Now, second question we'll read again. We have to get reactive power delivered by the generator. If everybody has attended last classes, I don't think there will be any problem in finding. We have drawn the power triangle. Again, we'll draw the power triangle of part number 2. Okay, let's draw the power triangle again here. Okay. Oh, sorry. I should go from bottom to top. This one here, and this one is okay. This is here, and then as I know, power triangle, this is phi, hypotenuse is complex power, and reactive power is in quadrature, and real power is here. So we always know S is equivalent to P plus GQ. This is basics of electrical engineering. From this, what we know, tan of phi, we have seen yesterday, Q by P. From this, I can get Q. What is Q value? It will be P tan of phi. Very important. Now, out of this, Q I know, Q has been given in 10 megawatts. So 10, this is in megawatts, multiplied by tan phi. Phi I know, tan, okay. Phi I know, phi should be cos inverse of 0.8. Okay, just okay. Okay, so let me add a page. Okay, so if you are able to get this value will be Q will be equal to somewhat 7.5 megavolt amperes reactive. So this is the unit of the reactive power, megavolt ampere reactive. So this is Q. Now if we have to find the Q value in per unit. So Q value in per unit will be the actual value of Q divided by the base value of Q. This is the actual value of Q. So actual value is 7.5 megavolts ampere reactive, and base value we already know. We are using the base of 25 MVA. So this together will give us a per unit value, and that will be 0.314 per unit. Very simple numerical. There's no problem as such. Okay. Part number 3. Part number 3, we have been asked to find the terminal voltage. That terminal voltage also in the per unit. Terminal voltage we have been asked to find in the per unit. Now terminal voltage, again the value will be same, actual value of the terminal voltage divided by the base value of the terminal voltage. Now actual value of the terminal voltage is given 5.6, we have seen it last time. Base value, we are using the generator base, that is 6 kV, and the value is 0.93 per unit. Very simple. Okay, last is your power factor. For power factor, again we'll be drawing the power triangle, impedance triangle. So this is your power factor. So for power factor, I will draw again this impedance triangle. Okay. Let me use it here. See, because in arrows and arrows together, they cannot coincide. Arrows. This is the problem with this. Okay. So here I will be using QPU. Here is SPU as usual. QPU. It's a complex power. Impedance, you can draw anything. But here we need a power factor. Power factor is basically what? Cos phi. Okay. Okay, Mumin. Mumin,
Yes, sir.
can you tell me what will be the value of the cos phi? Well in hand, before in hand. कल हमने ये derive किया था. We have derived this yesterday. It will be same value. ये कल मैंने कहा था ना ये change नहीं होता है. Let us see that.
एंगल चेंज नहीं होते.
निकालने की जरूरत नहीं है वैसे तो. 0.8. This is the absolute representation. Representation. It's absolute representation. Okay, so cos phi in per unit will be same P per unit divided by S per unit. As we know, cos sine theta, those formulas. This is your cos theta, base by hypotenuse. Base is, what is base? Okay, so I have not written here a base. Base is PPU. Base is PPU and hypotenuse is SPU. So that's the, or indirect cos phi is equivalent to P by S. So here will be PPU by SPU. Okay, so what is real power in the per unit? That is actual value of the power divided by the S base, because base will remain complex power. We have seen it yesterday. And what is the SPU? That is a complex power in the per unit. Actual value divided by the base value will remain the same, complex power value. So we can get simply this is equal to P by S. When it's P by S, so value in per unit as well as in real will remain the same. Per unit as well as real is per unit, that's absolute representation, and this actual representation and per unit representation value of the cos phi will remain same. So we will again, for your information, write it here. Cos phi in per unit and cos phi in absolute representation will have the same values. You don't need to find it. So power factor in per unit will be having same values at the power factor in the absolute system. You should remember it. You don't need to find it in the. I will make a small note here for your information. Power factor is the only quantity. Factor is the only quantity, okay, which is not, whose value will not change in PU representation. That means whatever the value is in absolute representation, the same value is going to be there in the PU representation. Is there any doubt? किसी को doubt है बेटा? Anybody? Is it clear to everybody? Roll number 22, Nida.
Yes, sir.
Nida,
Yes, sir.
बेटा clear है कि नहीं?
Yes, sir. Clear है.
16. Doubt है तो you can raise your queries. 46.
Yes, sir.
Okay, fine. 42. Davar.
Yes, sir, clear है.
Okay, then let's move. Okay, this was the first problem. It is very simple. Gate. Same problems will occur. Similar problems. All the problems are very simple, but you have to go through the basics completely. Now, at the end, I will be drawing the generator in per unit representation. generator in PU representation. This is PU representation we have. So what we can do, we can copy this and we can change the values. Here I can copy this. Okay, we need to copy it. Paste it here. Okay. So what we need to do, need to change these values. Okay. Okay. So this was here, the value was what? 0.00694. This resistance value was in per unit. And J was 0.03472. Just check it. And this is 0.93 in per unit terminal voltage. Value is always 1 per unit voltage. Okay. And this value was what? Basically 10 by 20 per unit plus J 0.314 per unit. Okay. So power factor is again same, 0.8 per unit. Let's check these values and you can draw this diagram. It's very simple. Okay, next is three-phase representation. Now how we are going to analyze the three-phase representation. Next is three-phase representation. Three-phase representation, but in per unit. Three-phase and per unit representation. How we are going to do that? Let's see. Okay. Okay, we have two types of connections that we know in a three-phase system. We have star and delta. So there are two types of connection in three-phase system. What are those connections? So number one, we have star connection. Okay, number two, we have delta connection. Let me draw the star connection first. Okay. So star connection is like this. Okay, so this is a star connection. We can have a impedance, the reactance here only. Okay. Okay, one more wire will be there. That is a neutral point. Also, this neutral wire will be there. So this we called R line representation. ABC you can represent also. That's your choice. But preferable is R by B. Three lines are there. So this is a current in the R line. So that will be I line. That means line current is there in phase R. I am writing between any phase and neutral. Okay, between any phase and neutral. Let's say R phase. So voltage will be VRN. That is between line and neutral. We normally call it VR, and that is nothing but V phase. Phase voltage is between any line and neutral. Between two lines, if we are talking about the lines, let me say R and Y. So this, sorry, I want to make it better. Let's say I have this line and I have this line. Now I'm going to okay, what is the value I am going to use? So this will between two lines. So voltage will be VRY. That means line to line voltage, or we also call it line voltage. That is V line. We simply say it V line. So this was something about the star connection. I think you already know it. So I'm just trying to uh, recapitulate the things whatever we have studied. So we have a line current, and you should always remember star connection. VL is equal to under root 3 V phase, and line current and phase currents are same in case of star connection. I think that you know. Those are the basics of. So let's move to the second type of connection we have. Second, this is the basics of this connection. Next is delta connection. So this is a delta connection. Let me draw the delta connection again. Now delta connection, you can see it's like this. Finishing end of one phase is connected to the starting end of another phase. Then it's like that is repeated for all the three phases. Okay. 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 So we have another line. Here we have another line. These are, I will draw again the reactance or impedance. Okay. So this is your R, this is your Y, and this is your me. No neutral will be there in this case. So this is your IR. That will be, it will be I line current in which phase? R phase. Then between two, this current will be called as, that will be line to line current. Yeah, line current IRY. Okay. And that between line to line, that line current is always equal to phase current in case of, that we know. In case of delta connection. So here in this case of delta connection, I line will be equal to I phase. Sorry, V line will be equal to V phase, and I line will be under root of 3 I phase. So this you have to remember. That I'm going to write here for your information. First is, what do you mean by line voltage? Line voltage. Okay. Voltage measured between any two lines. Voltage measured between any two lines is known as line voltage. Okay, so second is phase voltage. Phase voltage is basically what? Voltage measured across any single element. Voltage measured across any single element is known as phase voltage. It's very simple. You have studied them. Let me add another page. And we have line voltage, we have phase voltage, then we have line current and phase current. Sorry. We'll talk about the line current and the phase current. So line current is current flowing through any line. Current flowing through any line is known as line current. So very simple. Current flowing through any line is called phase current. Phase current is current flowing through any single component. Phase current, current flowing through any single component is known as phase current. So current flowing through any single component will be called as, what will be that called as? That will be called as the phase current. So these four definitions you have to remember. These four definitions you have to remember. Now let's go more details about the star connection. Star connection. Let's see more derivations in this case. These were the basics I have told you. Now star connection, you should always remember line voltage is under root 3 phase voltage. This you know. Line current is always equal to phase current. These are basics in the star connections. This is valid for the star connection only. Okay. So now, second, this is absolute representation. Now in per unit, voltages in per unit representation in case of star connection. VL per unit will be equal to, I told you that relationship, whatever the relationship exists in the actual system, same will be there in the per unit system. So that will be actual value of the line voltage divided by the base value of this one, VL base. So that will be VL divided by, we can write it symbolically, VLB. Similarly, VL per unit, again we can write, will be, what is the value of line voltage VL? Line voltage in terms of phases under root 3 V phase. What will be the base value? That will be also under root 3 VL. We can write V phase. We can say base. Okay, in terms of phase, again it will be the same. Relationship is not going to change. So that will be V phase divided by V phase base Okay, and that is actual value in phase divided by the base value in phase will be V phase per unit. So what we conclude here, we are concluding here that per unit same relationship exists between the phase values and the line values in case of star connection for per unit representation. I am repeating again, same value exists for per unit value of line voltage, and that means per unit value of line voltage and per unit value of phase voltage are same, whereas in actual system under root 3 is there. So per unit system in this three phase connections will modify sometimes the absolute representation either by removing the 3 or under root 3. This is a drawback in this system. So under root 3 or 3 by 3 will be uh, removed in the three phase representation. So what we can write here, we can write electrical relationship, same electrical relationship exists in base and per unit as in case of the absolute. We can write in case of three phase star connection, same relationship exists between line voltage in per unit and phase voltage in per unit, that is both values are equal. In other sense, they are both equal. So same relationship exists means the values are same. Okay, let's move further. Now, in case of per unit representation, VL per unit we have seen is equivalent to V phase per unit. So in case of per unit representation, we have seen this relationship. I will box it. Just now we have seen this. Now second is current in terms of per unit representation. Okay, current in per unit representation. Let's see. Again, we'll write IL in per unit. That is a line current in per unit will be what? It will be actual value of the line current divided by the base value of the line current. That will be IL base. And since in case of the star connection, both the currents are same, phase and line current. So I can simply write here I phase divided by I phase base, because both are same in case of star connection. So this will be I phase in per unit. So that means line current in per unit will be also same as phase current in the per unit. So we can write here IL per unit will be equal to I phase per unit. So that is second relationship. That's why the same thing, that whatever the relationship exists in the absolute system, same relationship will exist in the per unit system also. Now let's make a note here. What are the notes? This will be one of the disadvantages. Earlier we have not talked about this disadvantage. Number one, line current and voltages are same as phase current and voltages in the per units. That means line current and voltages are same in, okay, just a second, are same as phase current and voltages in PU representation. So that means line current and line current and line voltages, whatever the values of line current is there, same will be for the phase current in per unit. Whatever the values of line voltage is there, same will be for the phase voltage in per unit representation. Okay, second point to be noted is no factor of under root 3 or 3 is present. Okay, so what we can write, or you can write like this, uh, the factor of under root 3, no concept of under root 3 or 3 exists in per unit representation. Okay, second, no factor of 3 or under root 3 is present in three phase representation for three phase PU representation. We can write for three phase per unit representation. We can just take it off. Okay, for no factor of 3 or under root 3 is present in three phase per unit. We have seen that just now. I hope is up to here is clear.
Yes, sir. As much.
Okay, next is impedance base. Now, how we consider the, okay, third is impedance base. Impedance base. Let's consider this one now. Okay, impedance base. What is basically Z base? Z is V base by I base, as in the absolute systems. Same relationship will exist here also. Multiplying both numerator and denominator by V base. Right, VB also, this that doesn't matter. So that will be V base whole square, and this was S base. We have seen it earlier also. Same I am repeating. Now let me come to the single phase. Z single phase base value. How we are going to get it? So we are going to get it simply by V base. In terms of phase, we can write V phase square base value of phase divided by S single phase, and that is the base value. That means base value in single phase for a complex power, phase value of voltage. In case of, because phase value of voltage in terms of the face value of the voltage in terms of the base value, we can write it. Similarly, for the, if we have to find for the Z base for a 3 base, see, we are extending the result same for a single phase, V phase whole square base, and S base is single phase. So Z 3 phase we will write, just extending the results on the basis of the above relationship. Okay, so what will be, we'll be multiplying by 3 on the numerator and denominator, phase square base 3 as single phase base. Okay, so what is this? We can write this 3 we have multiplied. So in this case, Also, we can write, if we have to write this value, we can write this under root 3 v face base whole square. So we don't need to write that. So 3 and 3 will get cancelled if we have to write. Okay, let us write that also. This is simply I multiplied by 3 and on the numerator and denominator. So this can be also written as under root 3 v face base whole square. It doesn't matter, it will come under root 3 and 3 is same. So same result I am getting, divided by 3 face, single face, 3 faces will be there. So base will become 3 face base. These are 3 faces. 3 face multiplied by 1 face will be, for all the 3 faces base it will become. So if we have to write Z base for 3 face, for Z, if we have to write for a 3 face impedance base, what we have to write? We have to write this will become VL under root 3 V face is what? VL base. I'm trying to get this in terms of the line value. VL base divided by S 3 face base. I hope this is clear. In a single phase, V phase square divided by single phase base, multiply and divide by 3. This will become base for the 3 phase complex power, and in the numerator we can split this under root 3. We can write under root 3 V phase whole square, so that will be 3 here, and this 3 phase becomes for a 3. So we simply can write what? We simply can write VL square, because under root 3 V phase is equal to VL. That we know in case of the star connection. Okay. Is it clear or not?
Yes, sir.
Yes, sir.
Okay. Yes. Okay. Number 4 is power ratings. Number 4 is power ratings. Okay, power ratings, first of all, you should know. Everybody knows, I think. I will be just repeating all those things because these are very important. Complex power is given by under root 3 VLIL in terms of the line value. This is under root 3. So if I have to get the same complex power in terms of phase, then I have to write here 3 V phase I phase. Everybody knows that these are the very simple things. Real power in terms of line VL, IL, and cos phi. In terms of the phase value P, 3 V phase, I phase, cos of phi. Okay, then reactive power in terms of line under root 3 VL, IL, sine of phi. Okay, then reactive power in terms of phase, 3 V phase, I phase, sine of phi. This much of engineering everybody knows. This is the first basic electrical concept. Now let me talk about the complex power in per unit will be actual value of the apparent power or a complex power, we called it. Both can be used, divided by its base value. Okay. Now if I have to find the real power in per unit, that will be actual value of the real power, absolute value of the real power divided by base will remain here, complex power base will be there. Last is reactive power in per unit, that will be actual power of the real reactive power divided by the base will remain complex power base itself only. SB you can write, doesn't matter at all. Okay, so let me take this further. As per unit can be written as under root 3, because I am getting the absolute value in terms of line I am writing. So I am writing under root 3 VL IL. And I can write the value also in the base value also I can write like this, under root 3 VL base IL base. I can write as base like same, because values, the relationship will remain the same. Now here under root 3 gets cancelled. I can write here VL divided by VL base, and here I will write IL divided by IL base, and those two together is VL per unit and IL per unit. VL in per unit, IL in per unit. So I can simply write complex power as multiple of VL in per unit. Under root 3 will not be there. So that's what I am telling, that when you are using relationships in a three-phase system, there is a disadvantage that under root 3 and 3 will not be considered in the per unit representation. I am repeating this again. Okay, let's move to the second. Now let me get the same value in the, if I have to get the same value in the phase, as per unit can be written as, okay, I will use the same, instead of line I will write in the phase value, though that will be 3 V phase I phase, actual value of S I phase, what we have got earlier also in the previous page we have seen this, divided by, now actual value of S divided by the base value of S. That two base values will be in terms of the phase. 3 V phase base multiplied by I phase base. Now I am getting completely in the phase terms. 3 and 3 gets cancelled. So V per unit divided by V phase will be, that will be V phase, but value will be in per unit, multiply I actual value of the phase value of the current divided by the base value of the phase value of the current will be I phase also in the per unit. So under root 3 will not come into the picture again in this case. Now if we are talking about the real power now, P real power in per unit, it is under root 3 VL IL cos of phi in terms of the line values. Okay, now it will be actual value of the real power divided by the base value of the real power. So I can use under root 3 VL base IL base, cos phi will not change in either case. Okay, I am not using cos phi intentionally because cos phi and cos phi gets cancelled. So under root 3 gets cancelled. VL by V base is VL per unit. IL by I base will be IL per unit. Again, under root 3 in terms of line will vanish in case of per unit system. Same per unit I have to write in terms of the phase values. 3 V phase actual value in phase values, I phase, यहाँ भी cos लिख सकते हैं, no problem. Okay, just a second. हाँ, यहाँ मैंने cos phi लिखा था ना, हाँ, तो ठीक है. Yeah, cos phi is same, so can here use also cos phi. Cos phi cancel हो जाएगा, कोई बात नहीं. Cos phi, ठीक है. Actual value of the real power in terms of the phase values now will be the base value. Okay, sorry, no, यहाँ कुछ गड़बड़ हो गई हमें. Just a second. Okay, but P will be under root 3 VL IL cos phi. Okay, that is complex power is fine, but real power में हमने कुछ गलती की है. P will be, just a second, P will be under root 3 VL IL cos phi. That's the real power in terms of line. And then base is what? Base in per unit is this is apparent power. This is a S base. So S base is under root 3 VL IL. So that's correct. So we will get V phase per unit, I phase per unit, and then we'll get cos phi also here. Sorry, ये mistake थी. I hope this is clear. Real power is under root 3 VL IL cos phi divided by base value किस में होती थी? Complex power में. So complex power, what it is written in terms of the uh, line values. Complex power is under root 3 VL base या VL IL. तो यहाँ base है base. Cos phi उसमें नहीं आता है complex power. That's the apparent power. Okay, fine. Let's move ahead. So here in terms of this will be V phase base and I phase, because base is complex power, so cos phi will not be there. V phase by V phase base will be V phase per unit multiplied by I phase per unit. Again, I phase divided by I phase base per unit multiplied by cos phi. So this is in terms of the real power, how we write the real power in terms of the base values or the what we call it, base values or the per unit value. Last is Q per unit. So Q per unit will be doing that. After that, we'll conclude this lecture. So Q per unit in terms of line, Q is what? Under root 3 VL IL sine of phi. But base value is in terms of S. So that will be under root 3 VL base IL base. There will be no sine phi, because that is apparent power. Base value किसमें होती है? Complex SB apparent power में. So under root 3 gets cancelled. Actual value of VL divided by base value, that will be VL in per unit multiplied by IL in per unit multiplied by sine of phi. Okay, so this is in line values. Let us get the same values in case of Q per unit in the phase values. So that will be 3 V phase I phase sine of phi, because Q value will be in terms of this, whereas SB value in terms of phase will be 3 V phase base into I phase base. There will be no sine phi in this case because it's an apparent power. So if we cancel this, V phase divided by V phase base will be V phase in per unit multiplied by I phase in per unit, and then sine phi will be there from the numerator. So again, we have seen no concept of 3 or under root 3 in three phase per unit representation. Again, we can conclude this. So under root 3 and 3 will not come. Okay. So last is in generalized form, what we are going to write now, what we have to remember. In generalized form, what you need to remember, S in per unit is V per unit into I per unit. Same. Okay, sorry. Whatever the actual relationships are there, same will exist in the per unit. P per unit, how you have to write? You have to write that V per unit, I per unit, and actual relation is cos. Cos will be there. Q per unit, how you have to write? V per unit, I per unit, and sine phi. Sine phi will remain there. So if we are going to draw the power triangle, how we are going to draw this? Again, I am drawing for your information. Okay. Okay, I'm drawing up to here only. Okay, so this we know is phi. This is S per unit, Q per unit in quadrilateral, P per unit in the base. That's all. So that's all for today. We'll continue some more things we are going to derive in terms of this one in the next lecture. Inshallah, tomorrow we don't have a lecture, but day after tomorrow we'll continue. I will stop this first. Just a second.